Here's a model of the polymer polystyrene made from polystyrene. What we have here are these units made from polystyrene containers, lids, number 6 polymer that we've drawn on in markers and cut out, and he put them in a little toaster oven and shrunk them down. You may have heard of Shrinky Dinks that uses polystyrene polymer. We use container lids. You have to look for number 6 as a recycling code. And we have these arranged along a string here, along a polystyrene foam sheet. And I'm doing this to demonstrate a couple aspects about symmetry associated with polymers and different orientations. It turns out that these side rings, these phenyl rings, can be oriented in different ways. Here I have representation of the polymer in an isotactic geometry where all of the rings are on one side. Now, it turns out that you can also make a version of polystyrene in which the rings alternate sides of the polymer chain. And this is called syndiotactic geometry. Now, both the isotactic and the syndiotactic geometries are able to be made, but they're not used a whole lot. The most common form of polystyrene is said to have an atactic geometry, which doesn't really have any real organization as to which side of the polymer chain they're located. Some are located, it's sort of random as to which side of the chain these rings are located. Again, this is said to be atactic. This is the most common form of polystyrene used for many applications. It's not as ordered, and so it doesn't form as much crystalline structure as the other two forms, but it is perhaps easiest to make. It's really produced in the largest quantities.